Welcome to this session on data science. And this session is very special because it is a session which has a theme that data science for non-programmers. That's the theme of this particular talk because I've been presenting such talks on R, Python, hardcore machine learning. I've given several such talks. I've taken training. And by and large, uh, the sense which I get is there are a significant number of folks who feel data science and machine learning is for people who are from a programming background. But what I've seen is that it has been many cases where non-programmers were very successful data scientists, so they picked up languages like R and they were able to do data science. So with that experience, I thought of having a session exclusive on this, where I explain um, what is data science, how simple is it for even non-programmers to do using programming languages like R. And this is presented by Mationalytics. My name is Karthik. I'm the founder of Mationalytics. I also have a co-founder named Raghu who has been driving all these things in social media. We are predominantly a training and consulting firm. We do data science consulting and as well as data science training. We do both. We have taken a lot of batches so far on R, Python, data science, machine learning, so on, so forth. Okay. So when we sent the registration form, there was one question which say, "What did you expect from the course?" And one question or one thought which came, which I felt very interesting was, we want to know what is data science, which is a very genuine request because so much of gaga around data science, but still the concept of data science is not well explained in a crystal clear manner in one place. It's all people's perceptions, but there is no clarity around. So it's good that it came out when I asked for the comment. With that, let me give an explanation of what is this data science machine learning all about. And this session would be interactive, which means anytime you want to interrupt me, you could either paste in the chat window or you could unmute and speak up. Okay, so we are going to see what is that data science is all about. Okay, let's look at it from a Venn diagrammatic way. There had been a set of people who are mathematicians, statisticians, who are coming up with new statistical methods, new mathematical theorems without any end purpose in mind. They were done predominantly for the purpose of being invented, no applications being intended. So that has been a set of skills which has been there for several centuries, mathematicians and statisticians. And there is another set of people who have been doing business for again several centuries, because people, business, trade, all these things are happening for several centuries, and people have a deep knowledge in whatever business they do, be it doing some retail or any kind of banking or a different kind of trade or modern digital media stuff, whatever it is, people know their domain. There are people who run businesses who know their domain quite well. There are also business grads who also gain domain expertise and then uh, deliver business value. And there is this among these three, there is one new community which is computing. Well, I say new, computing itself has been there for 50 plus years. ever since the first computer was invented. Folks who build computing infrastructures, who come up with the new programming languages. Again, there is no real application intended, but having the best computing system, best softwares, all programming practices, etc., is the computing world. So all these three has been existing for a while. Even this has been existing for a while. Mathematicians and statisticians who apply that to solve some business problems. We've seen a lot of new structural equations for civil engineering applications, or people who come up with new optimization algorithm for supply chain management. So optimization is a mathematical technique. Supply chain is a business problem, and people doing research on that. This has also been there for a couple of centuries now, where you apply mathematics and statistics to solve business problems. This is new. The software boom, maybe last 30 years, where the computing infrastructure and programming languages were used to solve some business requirements. That's where software development comes into picture, where you use computing to develop some software which will cater to some business requirement. This is machine learning. Mathematicians and statisticians came up with a lot of learning algorithms. So algorithms which will help a machine learn, because we as human beings were taught in the past, we learned in the past, and then we are able to take decisions now. So in the same way, statisticians and mathematicians have proposed a lot of learning algorithms through which you can train a machine, and those were implemented as usable softwares again couple of decades back itself, where the learning algorithms which are proposed by mathematicians and statisticians as usable programs are the machine learning usable modules, which was also there for it's not a new term, it's been there for few decades now. What is relatively new is data science, using that machine learning to actually solve business problems. Apply machine learning to solve business problems is data science. So data science is nothing but use the mathematics and statistics which are pre-implemented in computing platforms to solve business problem. You teach a machine to make business decisions. So instead of a human being taking business decision, can you teach a machine and for taking business decision? That is data science. Use machine learning to solve business problem. So with that definition in place, are we good so far? Any questions? We have not really covered anything so far big, but any questions just to make the session interactive? Are there any other terms which you have heard, which you found, which you thought was data science, but now it doesn't look so, etc.? Would you like to share such terminologies which you have heard? Niba is good. Okay, let's move on. Can feel free to interrupt at any point in time. So with that definition of data science, let's get some more introduction to data science. First of all, we have to see why there is so much excitement about around data science. Why all this excitement? Because We are generating so much data. Every day we create 2.5 into 10 power 18 bytes of data. That's like humongous data being generated. And there is an interesting statistics which says 90 percentage of the data in world today has been created in last 2 years. So out of all the data which is present in the globe now, 90 percentage of them have been created in the last 2 years itself. We are just emitting data. Now I'm speaking, you are listening, we are sharing so much data between as I'm speaking, my speech is a data, the PowerPoint which I'm showing is a data. So much of data being floating all around and so much of data everywhere. So this is one cause for excitement because I am generating so much data. Can I make some sense out of it? Can I use them to do some business decisions? That has created definitely one excitement. Another excitement is people have already proven that using data science has helped their business. For instance, retail and manufacturing sectors have are one of the one of the early adapters of data analytics, and by using data analytics, their GDP alone, GDP of retail manufacturing alone in US is expected to go up to 325 billion by 2020. A very authentic forecast. And big data technology, data analytics, data science, big data, all put together is growing at a 23 percentage growth, and that itself is going to become a $50 billion industry in 2019. Heavy uh, uh, value expected, significant growth of data science. In addition to this, there are always talks about US elections across the globe, and of late, be it the Obama's term or Trump's victory, after the elections, there was a talk always about data science. So Obama used a lot of data science in his campaigns, and he was the one who had appointed what is called as chief data scientist. The first chief data scientist in White House was an Indian. He recently terminated. So DJ Patil, an Indian, he is the first US chief data scientist in White House. And Donald Trump again used a lot of data science, behavioral science for his campaigns, and his victory in Arizona especially was fueled by data science, and there was an Indian again behind that to uh, trigger that victory. So the data science and elections actually also created a lot of excitement on what is this data science, how come people are able to do, and there is a strong Indian connection to data science. And the other reason for the excitement is Google being able to make so much money using what is called as sponsored ads. So when we, let's say, you are two people in your home and you search for some terminology, let's say both of you at home are signed in to your Gmail ID, search the same term, you will see different advertisements for you and the other person because Google knows all our historical, our age, so we know we would have shared the date of birth, all our travel information, when we went, what all did we buy, what all did we search in the past, etc. Based on all our historical search terms, our profile, our Google Plus uploads, so on and so forth, it will prepare a portfolio of data about us and a portfolio of data about another person in your home, and both these will be sent to who are called as ad tech companies, and these ad tech companies will uh, do a bidding for this space, saying I want to bid for, let's say, $0.5 for this particular user, and the ad will get published. So top three bidders will get a space. So Google makes money by providing this real estate by using your data, and ad tech companies also on the other side are making money by knowing that people who have historically searched all these things, who are of this age, living in these regions, who have done all these kind of travels, would probably buy something like this. So it is game between models because all of this happens in a fraction of second. It is not a human being who looks at what you searched, your profile, push it, and there is another human being on the other side pushing the advertisements. Those all cannot happen. It all happens in a fraction of second, completely automated and completely driven by data science and machine learning. With this, Google alone is making $50 billion per year, and that country constitutes to 97% of the company's revenue. We feel Google is giving Gmail free of cost, Google Drive storage space free of cost. It's doing so many things free of cost, but it is doing it for a reason, because it's accumulating all those data and using them to make money in their sponsored ads. And it does it doing and doing by an auction. It just says, I have 3 spots left. Whoever are the highest bidders will get the space, and there will be competition between statistical models for the place, and whoever has high likelihood to respond to the ad, I will post the ad accordingly. Okay, so these are all things which actually created a lot of hype around this, but hype alone would not suffice. There should be enough jobs getting created for any new technology to be called as it is actually growing. People can speak about it, people can write blogs, people can tell whatever they want, like people can do sessions like me, but there should be real job growth happening, and there should be enough jobs created for things to be considered to be solid. And it is true. What I have done is I searched for two terms: IT jobs and data science jobs in Google Trends. So I searched for these two terms in what is called as Google Trends, and look at this. We all generally know that IT is in a declining phase, but all these are hearsay. We hear people terminated, etc. But it is a fact too. The number of IT jobs being posted is on a heavy decline. But on the other side, uh, this is the growth of data science jobs. Significant growth starting from 2014-15, and it is like a historical growth in the last 1.5 years. A significant growth of data science jobs, and decline of the general IT jobs, and this conveys a lot of message, and emphasizes people for reskilling themselves, because a big chunk of folks are going to get obsolete. The technologies, the skills which they have are turning out to be obsolete. And what technology and skill should I adopt? If at all there is one, it should be data science, because that's the significantly growing job position. You could see similar trends in, let's say I pulled it from Indeed. I searched for R, Python with big data, statistical analysis, data mining, data analysis, because people use different words, machine learning. Look at the growth. R as well as Python, significantly growth of jobs. Similarly, data science job growth in LinkedIn, heavy growth. This was again, I think, in Google Trends. This is SAS, this is R, and this is Python. So R as well as Python are, as such, data science is growing, and within that R programming and Python programming are significantly growing as. And there are some forecast as well from reliable uh, sources, like McKinsey projects that there will be 140,000 to 180,000 data scientist job opens by 2018 in US alone. That's a significant void which has to be filled for sure, and it has to be filled by people who are there, and which means even if someone has some partial understanding and gets the right skill, there is a high chance for someone to get a creamy job in the US, because there is already enough job openings in place, and there is a forecast that this is going to be accelerated, and there is going to be significant void in the uh, availability of data scientists. The scenario is green in India as well. NASCOM, which is an authority for any technology topics in India, had a conference a month back, and it projects that there is going to be an eightfold growth in the data analytics sector, and in India itself, it is going to become a $16 billion industry by 2025, and currently it is a $2 billion industry. Significant growth both in US as well as in India. So which means there is a clear void somewhere, and people who are early enough to sense this can go and fill the void. So we are at a level to see where all are data science used. We saw some examples of how Google is using, how it is used in elections, etc. I'm going to share across different verticals how it is being used. But before that, any questions on the general understanding of the job trends in data science? What are the skills needed, etc.? Does anyone have any questions on um, the employment opportunities around data science, which I could address and then move to the next section?
Nothing from me, Karthik.
Okay, thanks, Kavita. Okay, so data mining. So the question from Niba is there any relation with the data mining and data science? Data mining is a little bit of a legacy terminology now. I will trace back to in history when all this relational databases were there, all this SQL and varieties of SQL were in place. There were people who are managing the databases, but there are also people who are doing some querying, etc. uh, and At some point in time, people started writing very complex queries and then trying to analyze the historical data and generate some dashboards, create some insights on what happened in the past. That was called as data mining. So you mine the existing data and then get insights. So data mining is predominantly about insight generation from historical data. Let me cover what is data science from that. Data science is not only about getting insights from what happened in the past, but it is also about recommending for future, being able to predict what is going to happen in future, or predict what will happen if I do something like this, etc. So that's a difference, predominant difference between data mining and data science. Data mining is on looking at historical data and generate insights, but data science is understand the historical data and predict for future. So having said that, what is this data analytics? Data analytics now has become like a big umbrella term where one vertical is the big data and data engineering, people who do Hadoop, Spark, Cassandra, uh, uh, tool-driven teams who manage big data and make sure the storage and retrieval of data is fast enough. That is the big data engineering is one. Second being data science, people who use programming languages like R, Python, use machine learning and then do predictive modeling, data science. And third being people who are able to cater all these things to for business purposes who are called consultants. All these put together comes under data analytics. So to me, data mining is under the umbrella of data analytics. Data analytics has become a larger umbrella term. Does that answer your question, Eva? Thanks. Okay. Cool. Are there any other question? Okay. If there aren't anything, let me move on. We'll look at some. There are a lot of use cases which I have listed, but we will look at only few of them for a couple of minutes. Let's look at it by functions. In marketing teams, people do what is called as churn analysis. It's predominantly done by marketing teams of telecom companies. Let's say you have Verizon versus Comcast versus AT&T. Can I know before a customer leaves that a customer has intentions to leave? That's called churn analysis. I want to be able to predict whether my customer will leave me and join my competitors network. If I can sense that before itself, I can call them, ask them if they have issues, or give some kind of a promotional offer, etc. So this is done by looking at who were left in the past, what all kind of experience did they have before they left, and what were the reasons which triggered them to leave me, and are there any of my existing customers who are facing a similar experience, and if I can trace that, I would be able to shut any leaks if any, and excite the customer and retain them. So, and that is a machine learning. There are machine learning techniques to solve very popular churn analysis. Another one is, let's say, customer segmentation. I have 1 million customer base. Let's say Uber has a 1 million customer base, and Uber sends some promotional offer to me but not to my wife. So which means Uber treats me in one customer segment and my wife in a different customer segment. And how is it able to do? It would have it looks at several properties like what is the age, if it can trace some income, historical usage patterns, historical travel distances, historically what types of cars have been taken, what was the rating given to me, what ratings did I give to the chauffeur. Looking at all these things, the customer base is segmented into different groups so that Uber can send different promotional messages and offers for different groups in a customized way. Very popular. Uh, Another one is market mix model. Let's say I have a $200 million budget for advertisement, and where should I spend? How much should I spend in television? How much should I spend in print media? How much should I spend in Facebook ads? How much should I spend in Google ads? How much should I spend in local prints, newspapers? So all these decisions are taken using what are called as market mix models. Looking at historical experiences, historically you would have been spending your marketing budget, and what was the impact of each of these spends in the past on different scenarios, on different seasons of the year, and coming up with an optimized mixture of spending between different marketing channels. Whom should I target for discount? All under marketing. For salespeople, this is very important. I I get 1,000 inquiries, but which inquiry should I focus on so that there is a chance for me to convert it to a deal? There are 1,000 inquiries, but only 10 of them will convert to an actual deal. How do I know upfront that these inquiries have a chance for them to be converted to an actual deal? Based on that, I will prioritize whatever leads I get. Again, I could do that by looking at historically what kind of transaction actually converted, and with that I could apply similar logics on the available list of inquiries. Logistics demand forecasting. So uh, if I am automotive manufacturer, I have to be able to I should be able to forecast what is going to be the sales of each model of my car for the next 4 quarters at least, so that I could scale up my manufacturing, ancillary, employee, so on and so forth, based on the demand in the future. In banking and finance, risk analytics is very popular. Someone is applying for a credit card or a loan. Is he a good credit or a bad credit? There is a credit card swipe for a big amount. Is it really a fraudulent transaction or a valid transaction? Can I sense that the moment it happened? Quite some stuffs, but let's move on. By vertical, again, people do a lot of healthcare analytics, especially from an insurance standpoint. What is the risk for a patient to be readmitted? Based on that, I have to plan the claims, insurance related stuffs, etc. Readmission risk is very important in healthcare, because the insurance company is going to penalize me if I treat a patient and the patient gets readmitted. That patient is going to claim from the insurance agency, and the insurance agency is going to penalize me for having readmitted patients. Retail, what is the optimal pricing? If I have to open a new store, where should I open? How should I maintain my inventory? What all should I keep? If you have Walmart, uh, what should I keep? Should I keep egg, milk, cheese, meat together, uh, all laundries together? So, what does how does the general market basket of a customer look like? What do they generally prefer to choose together, so that I can keep them adjacent to each other? It's used in insurance, hospitality, life sciences. There is not even a single business which do not use data science. Okay, having seen that it has a lot of applications, there are so many jobs for R. Then see, why are we choosing uh, R? What is special about R for data science? What's the power and simplicity of R, which is making it trend in data science? The first aspect being it is a free software, because all legacy data science softwares like SAS, Minitab, even MATLAB for that matter, they are heavily licensed. The prices are significantly high. Organizations spend a lot of money on purchasing those licenses. And when all that is happening, there is a language which is so powerful and it comes free of cost, and you can use it for free for even commercial purposes. That is clearly one trigger. Second trigger being it is very simple to use. So even people who are non-programmers but have a logical thinking, they know what kind of business problem to be solved. If that larger acumen of problem solving is there, you don't really need to do some memory allocations, handle certain things, make sure you declare the right classes, objects. No, you don't really have to break your heads in programming. If you have a thought process in mind, converting it to a usable application is extremely easy using languages like R. You don't need any prior programming experience. You can just get started, uh, do a learning, and proceed with implementing your own solutions. And that is actually possible because of the strong packages which it has. There are 8,000 plus packages. Like, you can compare it with your Android apps, or apps in your iOS or Microsoft mobiles. Similarly, R also has apps which are called packages. But in case of Android or Apple, you will there are some of them will be free, some of them will be charged. But when it comes to R, all packages are free of cost, and there are 8,000 plus packages. No other language which is used for data science has so many packages. Anything you want, whatever you want to do in data science, there will be a package which is implemented in R. And when I say there are packages you have to install, etc., is it a too complicated a process for me to install? No. Installing is like a 30 seconds work, and it just sits nicely on the existing R whatever you have. And these packages are there across data access, data cleaning, modeling, visualization. So the packages are spread across the entire value chain of data analytics, and installing and using them is quite simple. The other worry which people uh, uh, have when it comes to free and open source languages is that, hey, should I type my program in some black screen, use some VI editor? I just don't know. I can't use my mouse, and it is too hard to even type out a single line of code. Is it so? No. It has a very sophisticated integrated development environment called RStudio. Again, that's also free of cost, where whatever you see in Visual Studio, Eclipse, NetBeans, all the most popular IDEs, RStudio is comparable with them. Great IDE which comes free of cost, and it sits on R, which is also free of cost. And another important thing is it has an amazing ecosystem of developers. It is not some open source thing which was developed 10 years back, but not at all maintained. But there is a release every quarter at least, and developers active round the clock trying to fix bugs if it is raised, helping people when they have some questions. A great ecosystem of developers. So any question one has in R, they could just post it in websites like RBlogger, Stack Overflow, etc., and you will get a response from the developers. It is the most popular tool for data science and machine learning. No other tool can be compared with R when it comes to data science and machine learning. And when you write a code, you don't need to write a different code for different OS. If you write a code, it will run either in Windows or Linux or Mac, whichever you want. And you don't need a big 16 GB RAM, the 1 terabyte hard disk. You don't need even that. Even a 2 GB RAM laptop is fine, because it is a very lean software, modularized software. It runs as with a very small footprint, and you don't need to really scale up your machine for doing data analytics. Whatever laptop you have, even if it has a 2 GB RAM, we are good to go to program in R. Last but not least, it you can do it for interactive work. You don't really need to program essentially. You can use it interactively, do some clicks, try some analysis, do some statistical analysis, etc. But finally, it is a programming language. You have to become an R programmer, but the transition will be smooth. From a mere user of a tool to a programmer in R, this transition will happen very smoothly when it comes to R. You will eventually write big R programmers, but you will learn it with ease, and the transition will be very smooth. Is it a new language? Not necessarily. It came even as early as early 90s, and have been frequent releases. In 2017, we had R3.4.1. Maybe there is another release after the time I saw. Frequent releases, frequent bug fixes, well maintained softwares. And what do we cover as part of training? We have two modules, one on R programming and another on machine learning. In R programming, we cover what are the data types in R, how do you do slicing and dicing of data, how do you write some control instructions like if conditions, for loops, etc. How do I do data processing in an optimized way? This is what is different, will differentiate from a an untrained programmer versus a trained programmer. How do you do things in an optimized manner? How do I process external files, write them back? The most important thing, how do we visualize the data? Visualizing data is extremely important for data scientists. You should be able to tell story about your data by looking at your data, and very interesting plots will be covered in visualization. Once someone gets comfortable with programming and the data processing, then comes machine learning, where all the important concepts of machine learning are covered in uh, enough details on theory, the practical applications, use cases, etc. Regression, clustering, classification, dimensionality reduction, time series analysis, and text analytics. These are the topics which are covered. I'm going to dwell into each of this topic, like give you a one-liner of one slider of each of them in a while. But I'm going to take a quick pause for you to ask any question you have on uh, why R, what's the use of R, and any questions you have on the training outline which I have provided. Okay. Since there aren't any questions, let's move on. Let's look at uh, uh, people would have who are kind of watching this data science space would have heard these words like regression, clustering, random forest, neural networks, deep learning, logistic regression, ARIMA, halt winters, so on and so forth, sentiment analysis. So we will decipher all those things. So what are the popular machine learning concepts? The first one, the mother of all machine learning algorithms, is regression. Regression is nothing but building relationship between attributes. For example, if you have if you know the weight of some people and their associated height, and this is like a data of a person with a weight of so many pounds and height of so many inches. Like this I have done for several observations, and I want to know if there is a relationship between weight and height. So here you see that as the weight of the person increase, the height also increases. As the weight increases, the height generally increases. And you keep hearing this word model. I have built a model. Model is nothing but this black line. That's the model. It's a line equation which is y is equal to mx plus c. Models are not too complicated. They are just some mathematical relationships. And regression builds a relationship like this, where it says height is so many times the weight plus a constant. Let's look at another example. I have advertisement spend in the x-axis and the sales in y-axis. If I spend more money on advertisement, I get more sales return. And based on historical relationship, if I build a line equation, the blue line which you see, I can actually then be able to predict for any sales spend. For example, if I want to spend $0.5 million, I can predict what will be the associated sales. Even without going live, even without really trying out, I can indicatively estimate saying if I am going to spend $0.5 million in the next financial year, from this blue line, I can actually predict what will be the expected sales because of that advertisement spent. The regression is used for predictive analytics of continuous values like sales, weight, height, etc. Next comes classification. Classification is in regression, you try to predict some continuous value like the sales, it's some number, height is some number. But in classification, It is not about predicting some continuous number, but predicting a class. If an email comes, whether it is spam or not. If a person applies for a credit card, whether he is a good credit risk or a bad credit risk. If I hear a song, uh, whether the composer is or the artist is this person or this person. So all these are classification problems. You don't really predict any continuous number, but it is a classification. Next is clustering. Without any target, if I know a lot of attributes, I was giving a Uber example, looking at all my attributes, my historical transactions, etc., I could do a segmentation of the observations. I could divide, for instance, this is uh, population measured across variables like education, income, and age. So based on these three attributes, I am grouping population. So high income, low moderate education group. This is low moderate income young group. This is moderate education, low income middle aged group. Like this, I can do a grouping. With this, I could do a lot of things. A government body can take policy decisions for each group separately. Uh, a marketing team can target different marketing campaigns for this. The sales team can decide different pricing strategy for each of this. Clustering very powerful to do some uh, customized decision making. Next technique is called time series analysis, where time is in picture. I know the historical pattern of data. My sales have been increasing in the past 4 to 5 years, and my sales generally increases during Thanksgiving. During the November December time, my sales increases. I see always see a peak in sales during November December. Having given this pattern on past, can I tell what is going to be the future sales? There are a lot of time series algorithms like ARIMA, Holt Winters, etc., which are used to predict what will be the future looking like, including the seasonality information retained. This is something which I'll skip for now. The last being text analytics. So far, whatever we have been seeing, this is like some sales data or passengers, number of passengers. Uh, this is age, income, education, numbers, advertisement, spend, sales, height, weight, all are numbers. But what if my data is text? Because of late, we all are speaking a lot in social media. We are posting in Twitter, we are posting in Facebook, we are uploading photos to Instagram. We are actually texting a lot, and a lot of organizations are watching whatever we are providing. If we say, uh, hey, Target, your Thanksgiving discounts are pathetic. If you if there are big number of people who show a negative sentiments towards Thanksgiving and Target can sense what is going on in the consumer's mind and accordingly take decisions. That's where text analytics comes into picture, because all machine learning algorithms will work on numbers. But if you have a text data, how do you convert it to meaningful numbers and then do some analysis? That is text analytics. So all algorithms you would have heard would have come under classification. Let's say random forest, naive bayes, decision tree. If you have heard of any classification algorithm, all will come under the larger classification umbrella. Okay, so that's it from my side on the concepts which I wanted to cover. We have around 30 more minutes which we can spend on trying out something. If any of you have R an R Studio installed. But before I jump on that, any questions starting from the beginning till what I've been covered till now? Do you have any question? Did this session give any additional clarity on what was missing before this session. If it was anything, then that kind of that is the expectation of this session. Whatever you felt was ambiguous, did anything get got cleared, or were you are you confused more, or are there any questions which could help you clear off some of the ambiguity? Okay, thanks Niba for the thing. Okay, cool. Thanks Revati. Okay, so having said this, let me I'm going to go to my R session. I'm going to show how what is R, how it works, etc. But before that, a quick check among the audience who have tried installing the R and R Studio and you were successful in doing that. Is anyone having it installed?
I have both the links that you sent in the email downloaded, but
Mm-hmm.
then the GUI doesn't look like what you are showing. One is, it just says R GUI
Mm.
64-bit something,
Okay.
and the other one, am I missing something? I'm not sure. That
Okay.
it just gives me like a DOS prompt. Like,
Yeah. Okay. Great, Kavita. So you've downloaded and installed both, right? Okay.
yes.
So I'm going to make you presenter. You will get a small plugin download request which you could accept. And if you can share your screen, uh, I could get the R Studio up in your laptop.
This is
Okay.
one.
So this
It's
is
my
RGUI. Okay.
and the other one. I think both are same, no?
Yeah, one is 64-bit, another one is 32-bit. So this both are same. Can you go to start and do a search for R Studio? Go to start. Okay,
Okay.
yeah, exactly, R Studio. Okay, it comes up. So now it will look similar to what I have, right, Kavita?
Yeah.
Okay. Anyone else tried installing? Niba, Piyush, Revati, Gomati. Okay, maybe you can. It will take a while to download. Okay, Revati has it. Okay, so there are uh, at least handful of you who have it installed. Let me give you a quick warm up for uh, how to program in. So this is R Studio, a very popular integrated development environment for R. And what you see here is called as a console, where you can do some quick calculations. Let's say you can use it like a calculator, 2 into 3, 2 by 3, 2 power 3, do some simple calculations, or say 3 into 5 plus 9 by 13 plus 4 power 2. Some complex calculation I could do. I can write some simple logics. A is equal to 2, B is equal to 3, D is equal to A into B, print of D. It's a small logic where I have assigned value 2 to a variable a value 3 to variable B, multiplying both, assigning it to a variable D, and printing it. On the right, you would have seen a global environment popping up. All variables which you have created will show up here. You don't really need to print and see, but you already have that in the environment. This is called a global environment. This is console. uh, RStudio has an inbuilt help. Let's say if you want to do some help of mean, it will give you a documentation of how to call that function, what will it return, based on which book was it pre-implemented, was it implemented, etc. will be shown in the help window. As I told, R is a package driven language. The list of installed packages will show here. Even in your laptop it will show a lot of packages because they come pre-installed. On top of it you can install a package if you want. You can click install. So you can ggplot 2 and then click install. A package will get installed seamlessly. So installing package, as I told, is not a big deal. It will get over in 30 seconds time. Whatever you typed historically in console will be saved so that you don't lose information. Generally all logics are written in scripts, so let me do file, new file, R script. I'm going to, let's say, save as, let me put it in my document. Let's say R try.
Someone has the air unmuted themselves, and there's a lot of air blowing on the microphone. If everyone is mute except Karthik.
Okay, also muted everyone. So it's I've saved it as R try, created a script. Let me also give a pause for whoever have R installed to try out certain things in console. Go to your packages list and see if you can create a new script and save the file.
Karthik, can you just show again how you created one of the script?
Yeah, file, new file,
Okay.
R script.
Thanks.
Okay, let's do some simple logics and see how easy is R. People who know even the basic programmings uh, know a concept called array. If you want to have some set of values saved, you can create an array. So to create an array is called vector in R. But let's keep the jargons aside. But array, how to create an array, there is a command called combine. For combine, the command is C. C is an operation for combining into a vector or list. So let me create array is equal to C of, say, I'm typing out some random numbers. 9. Okay. So to run a line of like this, you can select and do a select or keep your cursor and do a control plus enter. Control plus enter. So that's a comment. Anything you put after hash is comment. If you do a control plus enter, it will run, or you can select and click run. That will also run a line. What has it done? It has created an array. Print. It's an array of 1, 5, 2, 4, 13, 12, 9 values. It's the array. Let me paste these 2 lines code in the chat window for you to also try. Okay, so that there is an array. Let's have that aside. Let's say I have a number called, let's say I have a number 5. I want to know whether, or let's say I have any number x is equal to 5. I want to know whether x is odd or even. So how do we know? How do we calculate whether a number is odd or even? So I want to know whether x is, let's say, odd. That's the question. A number is odd when if it is divided by 2 and if the remainder is 1, it is an odd number. So I need a command which will give me the remainder. So there is a modulo operation called x modulo 2. This will give the remainder. X modulo 2 will give the remainder. So if x modulo 2 is equal to 1, then I can call it as an odd number. If x modulo 2 is equal to 1, I can say print odd number. So simple logic, you can write it with ease. Or I can say else print even number. So x is equal to 5, so it prints odd number. Let me put 6. This is even number. So I'm checking if the number is divisible by 2 and if the remainder is 1, then it is odd number, else it is an even number. Let me paste the code in chat window for all you also being able to copy paste and have it working in your screen. Now I am going to complicate the question a little bit. What I'm saying, I want to extract odd numbers from array. I have an array like this and I want to extract odd numbers like 1, 5, 13, 9. So I have to programmatically obtain the odd numbers from the array. Any thoughts? Any thoughts from a logical thinking standpoint? What shall we do?
Again, the question. From array, you want to remove
I want to,
all.
I want to extract.
Sorry.
I want only odd numbers. So my expected outcome is expected outcome is an array with values 1, 5, 13, and this is the expected outcome. I want a command which will give this outcome.
If array instead of X, if you put
Mhm.
array,
Okay, if array modulo 2 is equal to 1,
print. Hmm.
I have to extract though. So what shall I print?
Print C? No, array only, right?
Print array again? No, it will just print no, because you haven't really tampered anything on array. Who knows at least the basics of C? If you have to do this in a C language, let's say in C language you have an array and you have to do this, what would have been the thought process? Would we have not looped through each element of the array and checked each element whether it is an uh, array, whether it is an odd number, and then append to a list? Let me try it in C style, and then I will also tell you you don't need to worry so much to get this. But let's take a C style. We will write a for loop. Say for. Okay, so yeah, loop through each array member. That's the suggestion of Niba as well. We'll proceed. A for loop style is a little different. I for I in array. I'm looping through the values in array, and I'm checking if I modulo 2 is equal to 1. Let me create an empty odd num. I will create like an empty array, and to that let me append. So odd number is equal to combine of odd number with the I value. And finally let me print the odd. So I got the expected result. What did I do? I looped through the array elements. Each element I checked whether it is odd. If it is odd only, I am going and appending it to the empty list of odd number. I am appending to the odd number in the loop. So 1, 2, 3, 4, 5, 6. You needed around 7 lines of code if you have to do this in a C style. But R doesn't really trouble you so much. You could do it very intuitively. You could say array modulo 2. If you do this, it will return the remainder for each element. 1 modulo 2 is 1. 5 modulo 2 is 1. 2 modulo 2 is 0. 4 modulo 2 is 0. 13 modulo 2 is 1. 12 modulo 2 is 0. 9 modulo 2 is 1. So it in without writing a for loop, it actually inherently goes through all the elements and do this operation, divide by 2, and returns the remainder. On this, I can do a check is equal to 1. This will give me a logical output, whether it is true or false. I am checking whether the number divided by 2 is equal to 1 or not. If it is 1, it will give true, otherwise it will false. So 1 divided by 2, remainder 1, true, true, false, 4 false, 13 true, 12 false, 9 true. So you get a boolean output. which I can use to slice from the array. So my odd number is from the array. I'm extracting only things where my condition is satisfied. In one line, you get the 1, 5, 13, and 9. So for loops, which is considered to be one of the complicated things, is completely avoided. There would be only rare occasions where you will be writing for loops. Otherwise, there are very elegant commands to do even the most complex data processing in just 1 or 2 lines of code. So even a most complicated thing which will take probably 1,000 lines of code in C or Java, you could do it in 50 lines of code in a language like R. Very easy. Since you write only very less 9 lines of code, you will not make too many mistakes which will give trouble for you to debug. Let's do another example. Let's take the same array. I will ask you all to try solving. From this array, extract values above 5. From this array, extract value above 5. Line 24. Okay. Line 24. Let me split it into multiple things. I constructed step by step. Let me do. So I have a condition to check. The condition is that the number should be odd. Only then I have to do. I have a condition which I want to test. That condition is array modulo 2 is equal to 1. So this is a condition which will give me, it will do this condition check for each element in array. For each element, it does the conditional check and returns true wherever it satisfies. So 1 modulo 2 is equal to 1. Of course, it is true because it's an odd number. 5 modulo 2 is equal to 1 is also true. 2 modulo 2 will be sorry, go ahead.
No, I'm just trying to understand what's the difference between the one that you checked before on like when you said array modulo 2 is equal to 1. That time also we got this Boolean output, right? True, true, false, false. How is this different from what
No,
you're
it's the
trying to
same.
do?
I'm dividing since there was a question. I'm dividing it into 2 lines so that I've put the condition first, and I'm using that
Mhm.
condition to slice from the array. So in case if it was looking like a very complicated one-liner, I divided
Mhm.
into 2 commands. First command where I am checking the condition, and second
Mhm.
command where I'm using the condition to slice from the data.
Okay.
Yatish, is it a little better? Okay, so with that clarity, let's do this. Let's extract values from array which are only above 5. Let me paste the, I think the array was pasted. If not, I will paste the array for you so that you can also try it out. So from this array, I want values only above 5. Great. Niba has a solution. Let's wait for others. whoever else has a solution can paste. Okay, above 5 is okay, that's a condition. Aha, okay. That will give a logical, isn't it, Kavita? So let me copy your line. So you are doing a condition array greater than 5, perfect. And you will get a false, 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 true, true, true. But I actually want the values. So what I have to do is I have to actually from array above 5 is a condition. Mm, this 13, 12, and 9.
Okay, so that makes a difference, the way
Yeah,
you could in the
exactly.
parentheses.
Yeah, yeah. Niba, I think you were largely in line, but just that it should have been. If you want to do it in one line, array greater than 5 is the condition, and use that to slice. This is like above 5, above 5, 13, 12, and 9.
So the one that you just did on line 33 that Niba gave gives more sense. I mean, in one line you can.
Yeah, yeah. But sometimes if you have a very complicated uh, uh, stuff, right? Then it is better you uh,
Break it down.
break it down into multiple lines so that there is no ambiguity from a debugging standpoint. But with someone gaining experience, they do it in one line. But from a beginning standpoint, it is always good to break it down and make sure there are no errors. Okay, cool. So this is we could keep trying a lot of things, but my larger goal was to educate on what is data science per se, what is machine learning, what are these algorithms all about, and give a quick sneak peek into what is R Studio, how to write some simple modules here, so that you get started, and then if you feel like learning, etc., you get a comfort factor that it is a not a very uh, complicated thing, but it is a simple thing, tiny, nice tool to play around with. That was my plan for this session, which I am done with. What I will be doing is I will be I will share this script over email so that this is jointly developed by us, so you also have an ownership, so you can have this. I will also, the session is recorded, so I will upload this recording somewhere so that in case you want to have some future reference, especially on the concepts which I told on machine learning, etc., you could use that. So that's it from my side. Does anyone have any question?
If I'd like to pursue this further, how do we go about it?
Okay, so as I told, we are predominantly a training and consulting uh, firm.
Yeah, sorry, I
Uh,
missed the initial part of it. I
oh,
joined
okay,
20.
okay. Yeah, so we do professional training. We have ongoing batches on R, Python, machine learning, so on and so forth. So
Mm-hmm.
to pursue this further, what I will do is I will have Raghu, who actually created all these events, etc., to reach out to those who would be interested. He would be reaching out to all of you who were able to attend, and there he will be able to give you clarity on what would be the course content exactly, how long would it take, how much of assignment are there, because all my this is 100 percentage hands-on sessions which we do, which means you will be programming in class as well as there will be assignments, which means one has to commit around 120 hours of time to master this. So that commitment and what is the associated cost, etc., we will get in touch with you, Kavita, and we can speak.
Sure.
Okay. Does anyone?
120 hours when you said, sorry, I'm asking too many questions, but
Yeah,
when you said 120 hours, is it over a period of
a couple
what
of
is the
months.
time?
It would be over a period of 1.5 to 2 months time.
Okay. Okay.
And when we do that, we will also share some sample actual training recordings, which will be very similar. Like you had a problem in your to get launch R Studio. Similarly, people will be trying in class, they will have some syntax error. Ask them to
Mm,
share their screen, solve. Generally, a
mm,
batch would contain not more than 5 to 6 people, which means the class will not move unless until five or six who are there in the batch are clear about the concept. That's the mode with which we proceed.
okay.
Okay, great. Does anyone else have any other question? Okay, if there aren't anything, thanks a lot for joining this session. And reach out to you. You have our email ID in case any questions you have in the future. Feel free to reach out to us. We'll be glad to share the knowledge. Uh, uh, Thanks once again. I'll share the recording as well as the script. See you all. Have a great day. Bye bye.
Thanks, Karthik. Bye.